Dear students, good morning to all. Today we are going to learn about reactivity towards halogens for 16th group elements. Okay, 16th group elements like oxygen, sulfur, selenium, tellurium, polonium. These elements react with halogens to form different types of halides. These are 16th group elements: oxygen, sulfur, selenium, tellurium and polonium. These elements are denoted as letter M. Okay. These elements react with halogens to form different types of halides. That halides are: first one M2X2 type of halides, and next one MX2 type of halides, and next one MX4 type of halides, and next one MX6 type of halides. Okay, generally 16th group elements are react with halogens to produce different types of halides. That halides general formulas are: first category 1 M2X2 type of halides, next one MX2, MX4 and MX6. Some of the examples are taken. For example, S2Cl2. Sulfur is 16th group element, react with chlorine to produce this type of halide. And next one, oxygen, OF2, it forms OF2. Oxygen do not form MX4 and MX6 type of halides. Why? What is the reason? Oxygen is second period element. These elements having maximum covalency is equal to 4. Means these elements are formed only 4 bonds. These elements are formed, do not formed out of 4 bonds. Other means 5 bonds and 6 bonds are do not produced. Okay, that points are based on oxygen do not form MX4 and MX6 type of halides. Okay, and next one, sulfur. This is a third period element. It's react with halogens to produce MX4 and MX6 type of halides. For example, SF4 and SF6 type of halides. Generally, halogens are known as 7th group elements. So, these elements are fluorine, chlorine, bromine, iodine, and astatine is recently discovered elements, but halogens are fluorine, chlorine, bromine, iodine. The reactivity of halogens for 16th group elements are: first one, fluoride ion is more reactive than compared to others. Fluoride ion, chloride ion, bromide ion and iodide ion. This is the reactivity of halogens for 16th group elements. Okay, so SF4 and SCl4, but these two halides are observed. Which one is more reactive? Which halide is more reactive? Fluoride ion is more reactive than compared to chloride ion. Okay, this is the reactivity order for halide ions. And next one, these halides are observed. First one, SF4. SF4. The structure is observed: sulfur bind with four fluorine bonds, and sulfur having 6 valency electrons. Due to this atom belongs to 16th group elements. These elements are having 6 valency electrons. That 6 valency electrons, sulfur containing 6 valency electrons, that 6 valency electrons are observed. 4 valency electrons are participated for the formation of fluorine bonds, and remaining 2 electrons are involved for the formation of lone pair electron. SF4 structure is observed. SF4 structure is observed. Central atom sulfur containing totally 6 valency electrons. 4 electrons are participated for the formation of fluorine bonds, and remaining 2 electrons are involved for the formation of lone paired electrons. Finally, the structure is similar to seesaw shape. Okay, this is the structure of SF4. And hybridization of sulfur atom in this molecule, hybridization of central atom for the given molecule like SF4, totally 4 bond pairs and 1 lone pair, totally 5 electron pairs are present in it. Totally 5 electron pairs are present in it. These 5 electron pairs produces, the central atom exhibits sp3d hybridization. Okay, this is exhibits sp3d hybridization. And next one, similarly SF2 MX2 type of halide. So one of the another example like OF2. So I am going to discuss the structure of SF2 molecule. So this molecule belongs to MX2 type of molecule. So central atom sulfur containing 6 valency electrons. 2 electrons are participated for the formation of fluorine bonds, and remaining 4 electrons are involving for the formation of 2 lone pair electrons. Finally, total number of electron pairs are equal to 2 bond pairs, means 2 fluorine bonds, 2 bond pairs plus 2 lone pair electrons. This is one of the lone pair electron, this is one of the lone pair. Totally 2 lone pair electrons are present in it. Totally number of electron pairs are equal to 4. That point is based on the central atom in this molecule sulfur exhibits sp3 hybridization. sp3 hybridization. And next one, SF6. SF6. All MX6 type of halides in the respective group, all MX6 type of halides in the respective group like 16th group elements, these are exist gaseous state in nature. These molecules are exist gaseous state in nature. Okay. And the next one, these halides like 16th group elemental halides are participated disproportionation reactions. Disproportionation reactions. What is the meaning of disproportionation reactions. Disproportionation reaction means single step reaction. The similar elements, means one element means a similar element participated both processes like oxidation and reduction. That type of reactions are known as disproportionation reactions. Once again repeated in this definition, like disproportionation reactions. Disproportionation reaction means single step reaction, similar elements exhibits both processes like oxidation and reduction. That type of reactions are known as disproportionation reactions. One of the example is taken. First one, selenium fluoride. Selenium fluoride means M2X2 type of halide. M2X2 type of halides. So, selenium fluoride on decomposition to produce selenium tetrafluoride and a pure selenium is formed. Okay. In this reaction is observed, this is selenium fluoride. 2 moles of selenium fluoride is taken. This molecule is decomposed to produce selenium tetrafluoride and a pure selenium is eliminated. The reactant molecule central atom selenium oxidation state is calculated. 2x, 2 seleniums are there, 2x minus 2 is equal to 0. 2x is equal to x is equal to 1. X is equal to 1. And next one, x is equal to 4. X is equal to 4. And this is a 0. Okay. These are the oxidation states of different molecule. The reactant molecule central atom selenium oxidation state is +1. The product molecules like first molecule selenium tetrafluoride, that molecule central atom selenium oxidation state is +4. And next another product pure selenium, this oxidation state considered as 0 due to this is a homoatomic molecule. Homoatomic molecules oxidation states are considered as 0. Okay. So first one, the selenium oxidation state for reactant molecule +1. +1 is converted to +4. +1 is converted to +4. Means 3 electrons are loses. 3 electrons are loses. 3 electrons are loses. So the given reaction is observed, some electrons are loosed. The type of reactions are known as oxidation reactions. Oxidation reaction. And another half of the pot is observed, reactant molecule selenium oxidation state is +1 and another product molecule pure selenium oxidation state is 0. +1 is converted to 0. This step is observed. +1 oxidation, the selenium plus 1 oxidation state is converted to 0. Means 1 electron is gained. 1 electron is gained. 1 electron gained. 1 electron gained, that reactions are known as reduction reaction. That reactions are known as reduction reactions. Okay. So, this reaction is observed. This reaction is observed. The selenium, one of the step is observed. This is a oxidation step, and this is a second step is a reduction step. The single step reaction, selenium involves both the processes like oxidation and reduction. The type of reactions are known as disproportionation reactions. Finally, these halides like 16th group halides are participated disproportionation reactions. 16th group elements are participated disproportionation reactions. Okay. And final, one of the use for 16th group elemental halides, these are used to make mustard gas. For examples, S2Cl2 means this is also M2X2 type of halides. This is react with ethene gas with 1:2 ratio to produce mustard gas CH2Cl and CH2Cl. This is known as mustard gas. M2X2 type of halides are participated disproportionation reactions, and these halides like M2X2 type of halides are used to make mustard gas. This is a importance of 6th group elemental halides. Okay. So, this is an explanation for reactivity towards halogens for 16th group elements. Next, I am going to discuss preparation methods and properties of oxygen. Oxygen is one of the elements in 6th group in modern periodic table. Oxygen generally exists diatomic state in nature, like it exists O2 form in nature. Generally, oxygen exhibits two types of allotropic forms. One of the form is O2, means dioxygen, and another form is trioxygen. Okay. Today I am going to discuss preparation methods and properties of dioxygen. Okay. Oxygen exists diatomic state in nature. Okay. First, we are going to learn about preparation methods and properties of dioxygen. Okay. First one, preparation methods. Preparation methods. First one, sodium nitrate react with high temperature conditions to produce sodium nitrate and eliminated dioxygen gas. Means the thermal decomposition of sodium nitrate to produce sodium nitrite and eliminated few amount of oxygen gas. First one, to take 2 moles of sodium nitrate. These sodium nitrate molecules react with high temperature conditions to produce sodium nitrite, 2NaNO2, plus few amount of oxygen gas is eliminated. Okay, this is one of the simple preparation method for oxygen gas. Okay, simply the thermal decomposition of sodium nitrate. This is sodium nitrate. Sodium nitrate. Sodium nitrate. The thermal decomposition of sodium nitrate to produce sodium nitrite. Sodium nitrite. Nitrite. And eliminated few amount of oxygen gas. This method is observed low quantity of oxygen gas is liberated. Low quantity of oxygen gas is liberated. That is the main drawback in this method. But the quality of hydrogen is high, but quantity is low. One of the advantages in this method is quality is high and quantity is low. Okay, that is the importance in this method. Second preparation method for oxygen is the decomposition of KClO3, means potassium chloride, the thermal decomposition of KClO3 to produce 2 moles of KCl and 3 moles of oxygen gas is eliminated. The thermal decomposition of potassium chloride means KClO3, the thermal decomposition of KClO3 to produce 2 moles of KCl and 3 moles of oxygen gas. This method is observed. High quantity of oxygen is produced. In this method is clearly observed. This method liberates maximum quantity of hydrogen than compared to other methods. So this method is used to prepare large quantity of oxygen. Okay, so this is one of the important preparation method. And next one, the thermal decomposition of silver oxide. The thermal decomposition of silver oxide. The thermal decomposition of silver oxide to produce pure silver and oxygen gas is liberated. The thermal decomposition of silver oxide, the thermal decomposition of silver oxide to produce pure silver and eliminated oxygen gas. Okay. And next one, the decomposition of hydrogen peroxide. 2 moles of hydrogen peroxide is decomposed, means decomposition. The decomposition of hydrogen peroxide to produce 2 moles of H2O and 1 mole of oxygen gas is liberated. 1 mole of oxygen gas is liberated. Okay, these are the some important preparation methods of dioxygen. Okay, not oxygen, it is denoted as dioxygen. So these are the some important preparation methods of dioxygen. Okay, so first one, once again repeated in these preparation methods, like first preparation method, sodium nitrate react with high temperature conditions means the thermal decomposition of sodium nitrate to produce sodium nitrite and eliminated few amount of oxygen gas. This is the first preparation method. And second preparation method is the thermal decomposition of KClO3 to produce KCl and few amount of oxygen gas. This method plays very important role due to this method is used to prepare large quantity of dioxygen gas. That is the importance of this method. And next one, the thermal decomposition of silver oxide to produce pure silver and oxygen gas is liberated. And finally, the decomposition process of hydrogen peroxide to produce water molecules and oxygen gas. And electrolysis process of water, that process is observed, oxygen is liberated at anode. That is one of the important preparation method. Electrolysis process of water, that process is observed, that process involves platinum electrodes. That process is observed at anode, oxygen gaseous molecules are liberated. That oxygen is exhibits high quality. Okay, that is the one of the important preparation method for oxygen, means dioxygen. Okay, so next one, properties of dioxygen. Properties of dioxygen. Generally, dioxygen is used to make oxygen cylinders. These oxygen cylinders are used in hospitals. So generally, dioxygen dissolved in water, for example, 3.1 centimeter cube volume of oxygen dissolved in 100 ml of water. Okay, this oxygen is known as dissolved oxygen. Okay, this oxygen is known as dissolved oxygen. And next one, so many advantages of dioxygens are there. Some of the applications are observed. Generally, dioxygen is used to make oxygen cylinders. These are used in hospitals. And this dioxygen is used to make different types of molecules. For example, for the formation of sulfuric acid, dioxygen is plays very important role. So, and next one, for the formation of nitric acid, so that process involves dioxygen gas. So these are the some important applications of dioxygen. And next one, chemical properties of dioxygen. Chemical properties of dioxygen. Chemical properties of dioxygen. Okay, First one, dioxygen react with metals. Dioxygen react with metals. Metals react with dioxygen to produce metal oxides. To produce metal oxides. Metal oxides are exhibits basic in nature. These are exhibits basic in nature. Okay, for example, alkaline metals. These are the powerful metals. Alkaline metals, first A group elements, react with oxygen to produce different types of oxides. For example, lithium react with oxygen to produce normal oxides. First category, normal oxides. Normal oxides. These oxides, normal oxides, that molecules oxygen atom oxidation state is -2. -2. On moving down the group for alkaline metals like sodium, potassium, these elements means these are also metals. These elements react with oxygen to produce peroxides. Peroxides. These peroxides, each oxygen oxidation state is -1. -1 oxidation state is exhibited. And the third one, alkaline metals on moving down the group like cesium, this element react with oxygen, excess amount of oxygen to produce superoxides. Superoxides. These superoxides, each oxygen oxidation state is each oxygen atom oxidation state is -1/2. Okay, so these are all metal oxides, but some metal oxides are exhibits normal oxides. Some metal oxides are exhibits in the form of peroxides. Some metal oxides are exhibits in the form of superoxides. What is the difference between normal oxides, peroxides and superoxides? Only difference is the oxidation state of oxygen atom. In case normal oxides, each oxygen exhibits -2 oxidation state. In case peroxides, each oxygen atom oxidation state is -1. In case superoxides, each oxygen atom oxidation state is -1/2. This is explanation for metal oxides. And next one, non-metals. Non-metals react with oxygen gas. React with oxygen gas to produce non-metal oxides. To produce non-metal oxides. To produce non-metal oxides. Okay, non-metal oxides are exhibits acidic in nature. Non-metal oxides are exhibits acidic in nature. Acidic in nature. Okay, all non-metal oxides are exhibits acidic in nature. And next one, third category of the elements in modern periodic table, metalloids. First category metals, second category non-metals. Metals are attained bottom side of the modern periodic table. Non-metals are attained upper side of the modern periodic table. Means these modern periodic table cutting with diagonally. So bottom side are arranged metals. So above side are arranged non-metals. On the surface of diagonally diagonal line, so that are attained, that portion is attained metalloids. Metalloids react with oxygen gas to produce metalloid oxides. Metalloid oxides. So metalloids means these elements are exhibits both acidic in nature and basic in nature. Means both characters like metallic character and non-metallic character. So metalloids means such elements or exhibits both characters like metallic character and non-metallic character. The type of elements, best example aluminium, react with oxygen gas to produce metalloid oxides. Best example aluminium oxide Al2O3. So metalloid oxides are exhibits both acidic in nature and basic in nature. Both characters are exhibited. Okay, so these are the different oxides in different types of elements like metals, non-metals and metalloids. Finally, oxygen is used to make sulfuric acid and nitric acid. For example, for the preparation method of sulfuric acid, sulfur react with oxygen to produce sulfur dioxide. So the sulfur dioxide is unstable gaseous molecule. The sulfur dioxide is unstable gaseous molecule. The sulfur dioxide react with oxygen gas to produce stable sulfur trioxide gas. To produce stable sulfur trioxide gas. The sulfur trioxide gas is used to make sulfuric acid. This is one of the application for the preparation method of sulfur trioxide. Oxygen is used to make sulfur trioxide gas. The sulfur trioxide gas is used to make sulfuric acid. And next one, for the preparation of nitric acid, that process is observed. The unstable nitrogen monoxide. The unstable nitrogen monoxide gas react with oxygen gas to produce nitrogen dioxide gaseous molecules. Nitrogen dioxide gaseous molecules. These nitrogen dioxide gaseous molecules are used to make nitric acid. Okay, to make nitric acid. Finally, oxygen gaseous molecule means dioxygen is used to make sulfuric acid, and the dioxin gas is used to make nitric acid. Finally, this dioxygen gas is used to make chlorine gas also. For example, hydrochloric acid, 4 moles of hydrochloric acid react with oxygen gas. 4 moles of hydrochloric acid react with oxygen gas to produce 2 moles of water. 2 moles of water, and next one, 2 moles of chlorine gas is liberated. 2 moles of chlorine gas is liberated. Finally, the dioxygen is used to produce chlorine gas also. These are the some important properties of dioxygen gas. Once again, repeated in these chemical properties, like first one, metals react with oxygen, means dioxygen, to produce metal oxides. These metal oxides are exhibits basic in nature. And second one, non-metals react with oxygen to produce non-metal oxides. Non-metal oxides are exhibits acidic in nature. And the third category is metalloids. Metalloids react with oxygen gas to produce metalloid oxides. Metalloid oxides are exhibits both characters like acidic in nature and basic in nature. And next one of the important point for metal oxides are formed 3 different forms. First form is normal oxides, second one peroxides and superoxides. First A group elemental oxides are observed, these are metal oxides, but some of the elements are formed normal oxides like lithium react with oxygen to produce normal oxides. And the next one, sodium and potassium, these are react with oxygen to produce peroxides. And a cesium, last element in first A group element, cesium react with oxygen to produce superoxides. All are metal oxides, but what is the difference? Normal oxides, peroxides and superoxides. Normal oxides, these oxides, each oxidation state is -2. Next one, in case peroxides, each oxidation state is -1. In case superoxides, each oxidation state is -1/2. This is a difference. Means oxidation state is different. Only the difference is oxidation state of oxygen in different metal oxides. Okay. So that is a specialty of metal oxides. And next one, oxygen is used to make sulfuric acid, nitric acid, and next one, chlorine gas. So for the preparation of sulfuric acid by using contact method, unstable sulfur dioxide react with oxygen to produce sulfur trioxide. This sulfur trioxide react with sulfuric acid to produce oleum, that is diluted to produce sulfuric acid. Okay, that is the preparation method for sulfuric acid. And next one, for the preparation method of nitric acid, the unstable nitrogen monoxide molecules react with oxygen to produce stable nitrogen dioxide. This stable nitrogen dioxide react with water in the ratio of 1:3 to produce nitric acid. And finally, oxidation of hydrochloric acid to produce chlorine. These are the important chemical properties for dioxygen gas. Okay.